Robert Spragg up to talk about ultra-high performance concrete overlays for highway bridge decks. His current research focus is on the durability of cementitious materials as they relate to accelerated bridge construction techniques.
I'm going to be talking about the use of ultra-high performance concrete on highway bridge decks and specifically looking at bridge deck overlay applications of this type of material. So UHPC is gaining popularity in the United States. Here's a picture of the projects that we have kind of kept track of that have happened across the United States since 2016. If we look in the region that is probably of most interest to the people in this room, we see that there are a fair number of projects. So maybe some of you in the room have had the opportunity to work on a UHPC project. These projects include lots of different types. We're going to be focused on the particular application of bridge deck overlays for this presentation. So just to give a quick outline, I'm going to go through what is UHPC, just a quick background, and then what makes it unique for this type of application. Where this has been used in bridge deck applications, we're going to look at one application in Switzerland and then three lower volume roads here in the United States, or lower volume bridges. And then we're going to talk a little bit about the ongoing research that we're conducting to try and answer some critical questions moving forward. To define and give some general properties of UHPC for those of you that maybe haven't had a chance to test it in your lab, it is a cement-based material. It usually is made of granular components, so it doesn't really have any coarse aggregate. It has extra fine aggregate, but not really even any sand in it at all. It has a relatively low water cement ratio of 0.25. It does have fiber reinforcement, and most of the time for structural applications, these are steel fibers. It has greater than 21,000 PSI and then greater than 700 tensile strength. And then it has a lot of other properties that are also important. Again, it's made of traditional materials, so you would recognize a lot of the materials that go into this product: Portland cement, supplementary materials, fillers, and then admixtures and fibers. The real special part of these materials come in how they're blended together. So they're blended to try and minimize the porosity. So if you could imagine a volume distribution of sizes here along the bottom, we have different particle sizes. We blend these together to try and make an optimized gradation to minimize that porosity. This might look like, or a video, I guess. So UHPC in most typical applications it's used is used in the one that's on the left. So this is like a self-consolidating material. But in the applications where you're worried about a bridge deck that might have a super elevation, you would probably want to add what they call a thickening agent, basically to make sure that it doesn't really move around too much or kind of flow off your deck into the water below or anything like that. We call this type of behavior, right, that it really only moves when it's being vibrated, but when you take away the vibration, it stops moving. We call that thixotropy. So this material is thixotropic. Compression behavior, very similar to normal concrete, except maybe a little bit higher. The real special part of UHPC is its sustained tensile behavior. So you're able to reach about at least 700 PSI, and then also it's able to sustain that over a larger amount of strain. UHPC is available from a lot of different manufacturers. There are commercially available options. A lot of times as these are included in the bid packages that we have seen, they've been included along with some material on-site quality control because they are kind of sensitive to admixture or to water content. So typically the producers will kind of batch that all together. For a typical application, the price is very comparable. We'll see in the next slide some actual numbers on this. But typically you're also using a lot smaller quantities when you're using this higher performance materials. As far as where the costs come from, most of these are the price of the steel fibers is significant, especially with the requirements that for a lot of federal projects were partially funded federal projects, that they are purchased from an American manufacturer. And this can be up to 60% of the cost. Just because I have to put in this disclaimer, you sometimes have to be cautious on what we've called homemade UHPCs, right? So this would be, you have a ready mix producer that says that he's able to get these type of properties that we listed on like the second slide in a concrete mix that they can do in their truck. There's a lot of development that went into making sure that it has the right kind of bond to the concrete, that it has the right kind of development length in your steel reinforcement and things like that. So you would have to make sure that you look at those properties for that particular developed homemade UHPC. So here's some typical quantities and prices. UHPC is typically more expensive. It's a highly engineered material, so it is going to be a little bit more expensive. But the benefit that you get is you don't have to use it in the same quantities that you would a traditional concrete. This slide is actually wrong. It should be dollars per square foot on there on the table. These are actually estimations that we've done from some of the literature and some of the projects that we've looked at, but these are only materials related costs, so they don't include installation. They're probably very different than a line item that you might see on a bid, so don't let that confuse you too much. But you can kind of see that for the most part, UHPC is in the neighborhood of some of these materials, and then of course the added benefit of the durability that you get from that material is a good idea. Looking at some typical applications that we've seen in bridge decks. So again, we're going to talk about 4 projects. The Xi'an Viaduct in Switzerland. This is a nice project to talk about because it's a signature structure. It was very difficult for them to take out of service, so I imagine that a lot of you have that experience that you can't tell people that you're going to close down an interstate bridge. And then the other 3 projects that have taken place here in the United States have been low volume roads, either rehabilitation or new structures, but they have been on typical applications where that wasn't a main concern. The Xi'an Viaduct is a bridge in Switzerland. Here's some photos of what that might look like. Here is the existing structure. You can kind of see that it looks very slender, I think. I saw it and I was like, wow, that's kind of glad I don't drive in Switzerland. So they were putting a 1.5 inch or 1.6 inch UHPC overlay on the top. So this particular application was not necessarily looking at rehabilitation, but they were also including some strengthenings along with that. So they did some calculations that this was, the primary goal was to increase the structural capacity of this bridge. But it gives us a nice example of what this would look like if we were to implement this in the United States on a big structure. So again, you would have the bridge, the current in-service bridge deck that they hydromilled, and here's the kind of an example of how they did the hydromilling. And then the actual where the UHPC overlay was going to be placed, I guess my pointer. So they did put a reinforcement mat there, and then here are some pictures of what that looked like. Casting the UHPC was, they had a special machine that actually brought out the UHPC. They had it in a hopper, they put it in here, and then they kind of placed it with this one lane wide placement machine. Transitioning to projects that have happened here in the United States, this is one that happened in Brandon, Iowa. So you can kind of see it's a relatively low volume road, of course. But here's a picture of what the deterioration on the deck looked like. So you can see some spots that a significant amount of spalling. Again, they did put some reinforcement. That's kind of depending on the design of the overlay, whether you would need reinforcement or not. And then, of course, in the large potholes that they cleaned out, they also put some rebar in there as well. And then they hydromilled prior to putting the overlay. They did do hydromilling on this deck, so you can kind of see that's what this kind of surface profile looked like, and we'll see some more pictures under the microscope here in the next couple slides. And then this is what the overlay casting looked like. So you would have this vibratory bidwell that they were just pouring the overlay and then kind of pulling it along behind them. And then this is what the final product looked like, again with a grind and groove there on the surface. So we were able to go out to visit this project and bring back some samples and do some testing in the lab. One of the main things that we're concerned about with overlays is how well the overlay has bonded to the substrate concrete. So sometimes you could imagine using like a bond enhancer or like some epoxy-based bonding agents. UHPC has a relatively good bond strength or bond characteristics, but we were confirming that with what we've called a direct tension pull-off test. So that's a picture of that is up here in the top right corner. You create a partial core and then you attach your pull-off disc, and then you have a pull-off machine that just kind of pulls that disc off. So assuming that you get failure at the interface, which is most of the time, if the glue is good, you get failure at the interface, then you can calculate what your bond strength was. Right, so here's what the data looks like. Looking at field data and laboratory data, you can kind of see that the scarification was a little bit lower than the hydrodemolition, and then some of the other ones that we looked at as well. And the reason for that is that it has to do with how well the overlay is consolidated, and then also damage that might happen to the aggregates during the scarification or the hydromilling process. And we'll take a look at that in the next couple slides. To give you an idea, I don't know if anybody has ever had the opportunity to look at concrete under an SEM. This is kind of what it looks like. So you would have your substrate concrete, right? You can see the black portions are the holes, so the round black portions in the substrate concrete are the air entrainment that was in your in-place bridge deck. And then the UHPC that was put on top of it. So the interface there is the bright yellow line, and then that interface that we measured hydration products along that interface as it extended into the UHPC. Then you can also see the steel fibers. Those are the parts in white. So white represents density. So white means higher density. So you can kind of see on average the UHPC is denser than the concrete below it. But when we took these samples from this project in Iowa back to the lab and we looked at them under the SEM, we could see that we did end up with cases where there are poor consolidation. So that's one of the key things that we're looking at moving forward is how can we ensure that this UHPC overlay is well consolidated. So you can imagine the video that we showed in the first couple slides where you have a self-consolidating material. Well, of course, that consolidates very well. But in an overlay where you have super elevation on your deck, it's really hard to use like a self-consolidating material. So you're going to have to use this thixotropic formulation that you have to make sure that you put enough energy into it that it does consolidate and has good bond strength. And then looking at the substrate preparation, there was one particular pull-off data had a little bit lower bond strength. That was this preparation method here. So you can see the scarification method really kind of, in this particular application, kind of damaged the aggregates. So when we were pulling off our sample, it was already kind of attached to a damaged substrate, which we think led to some of the premature failure. You can see diamond grinding does do some damage. I don't know if I've zoomed in far enough here on the photo, but this big gray piece here is a piece of aggregate that does have some microcracking in it. So that came from the diamond grinding process. And then hydromilling or hydrodemolition was another technique that we saw. And so far, we've really liked the hydromilling or hydrodemolition process because it doesn't seem to damage very much of anything. So it'll blow away the paste for the most part, but it doesn't really cause any damage that we've been able to see under the microscope. But when you're looking at, if you happen to be looking at a particular substrate preparation method prior to an overlay, it's important to look for something that has both micro and macro texture. Right? So the hydrodemolition has that micro texture because you're exposing some of that aggregate, but it also, the way that they do it, has like a macro texture to it. So you can kind of, if you got down and looked at it, you could visually see that a wavy pattern is there. So that really helps to increase the tensile bond strength, but also the shear bond strength, which is another important parameter. Another project was this is actually a new construction in Delaware. They are adjacent box beams that were cast with a UHPC closure pour. And then after the closure pour, they came back and put a UHPC overlay on the top. So here's an example of what the connections look like between the box beams. And then this is the closure pour between the box beams. So this is UHPC. This would be the UHPC that is self-consolidating. And then this is them coming back and putting that overlay on the top. So the vibration you hear is actually the vibration of the bid well. So that's trying to make sure that they're providing enough energy into that thixotropic material so that it does flow enough that it does have that good kind of bond characteristics. And then they would just slowly crank it across the surface of the deck to try and move it along in front of the material. So you can kind of see how the material, once you pour it, it doesn't really go anywhere, and then they have to like spread it out with their rake for their kind of thing. And then the last application is one, an overlay that they were doing in Sheldon, Iowa. Again, this was a rehabilitation project. They were doing an inch or 1.75 inch overlay. They did do hydrodemolition, and then they used that UHPC placement machine that came over from Switzerland. So as far as research activities that we're doing at Turner Fairbank, we are looking at at substrate preparation methods with and without active corrosion in your rebar. There's been some concern about how much you have to, whether you have to excavate the rebar and stop the corrosion and then put your overlay, or there's some people that say, well, the overlay, the UHPC overlay will keep out any moisture or oxygen, so which could kind of kill the corrosion reaction, so we're kind of investigating that. We're looking at mechanical and durability performance of UHPC interfaces. So you could imagine if you're pouring adjacent lanes, you'll have a cold joint between those lane pours is kind of a cold joint. So we want to make sure that there's no concern of chlorides or moisture getting down between that cold joint and then kind of propagating along the interface between the overlay and the concrete material itself. We're looking at fatigue behavior of overlaid deck elements, and then lastly looking at life cycle cost comparisons with other rehabilitation techniques. And really there we're trying to look at the motivation and making sure that we're providing the best value of whichever overlay rehabilitation technique you decide to use. So there are lots of resources available if you would like to look at overlays or specifically UHPC overlays. We have a research website along with a couple reports, some summaries of some of our field visits, a couple journal papers that are peer reviewed, so at least you know that we're not just the crazy ones that say it ourselves. Somebody else has looked at it. And then lastly, you can feel free to call or email any of the members of the research team, which their emails are here. So if you have any questions, feel free to email us. I guess I'll take any questions. Sure. So the costs that we have here, so these are material-related costs for the projects and the bids that we've looked at. So these don't include placement costs. They're not bid line item values that you would see in a bid. So don't get confused by that. And it should be US dollars per square foot. But you can kind of see that the UHPC or the proprietary UHPC, which are most typical applications would probably be a proprietary UHPC just because there are a lot of engineering that goes into making these materials. Probably on the order of anywhere from $10 to $20 a square foot for the material.
curious about concern over cracking, or if a structure's flexing, how that would affect the overlay?
Sure. So do you mean like, so after you place the overlay, then traffic and things like that causing loading that could? Well, I will say that so you can kind of see here that there's a lot more ductility with these type of fiber reinforced materials than traditional concrete materials. So you would expect, and especially with the large fiber content, so up to 2.5%, or even the overlays are up to 3.5% fibers. So that really helps to distribute the cracking you might see. I don't know if I would be able to give you an exact number, but I think that the fibers distribution would help distribute the cracks a little bit better. I'm not sure I could tell you that one. I would have to get back to you on that. So these materials do have a relatively low water content, so you would have to make sure that they are protected from evaporation. In this project in Delaware, they actually, I believe they put like a plastic sheet on the overlay as they cast the overlay. They were placing a plastic sheet on the overlay behind it. But you do want to make sure to protect it from evaporation, whether it be a curing agent or something like that. This technology was pioneered in Europe. I know that they've been in service in Europe for about 20 years. I'm not sure. I couldn't tell you what condition they were in. But the earliest one that we did here in the United States was this project, this prior project in Iowa, and I think it's been about 3 or 4 years. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.